atmosphere is a magnificent sea of air. But like the oceans surrounding our continents, this immense canopy stretching over them has its own share of natural dangers. Hailstones can cause structural damage or even structural failure. Freezing drops of water can enclose its front edges in an ever-thickening block of ice. Reduced visibility can tie a blindfold over the eyes of its pilot when he's trying to land. Lightning can burn out its electronic instruments. Violent turbulence can sometimes cause complete loss of control. Your weather flight problems will sometimes be associated with clouds of one type or another, and in order for you to anticipate these common sky objects, you must be able to identify them. Meteorologists all over the world recognize 10 basic clouds of distinct shapes, shades, and altitudes. This film will identify these 10 clouds with their symbols, show their altitudes, show how, when, and where they develop, describe their principal characteristics, and discuss their flight hazards, if any. All clouds are created by the condensation or sublimation of moisture in a cooling atmosphere. Whether this moisture steams from the spout of a boiling teapot or evaporates from a water surface. The moisture is first an invisible gas or vapor in the air. As this moist air is lifted in the atmosphere by vertical currents, the air gradually expands like a rising balloon. The expansion and cooling of this air continues. And then, rather suddenly, its invisible moisture condenses or sublimates into a visible mist or cloud made up of billions of tiny droplets of water or ice crystals. The temperature level where the cloud develops is called the dew point, and its Fahrenheit or centigrade reading depends upon the original degrees of humidity in the atmosphere. When air is damp, it may not have to drop very many degrees before it reaches its dew point. Dry air, on the other hand, may cool many degrees below freezing and not become saturated. Some of what we call weather comes about when large masses of air of different pressures, temperatures, and moisture content come together. In much of the USA, for example, there is frequent conflict between warm, moist air masses coming up from the Gulf of Mexico and cold, dry air masses coming down from the Yukon and other inland regions to the northwest. The boundary between these air masses where they come in contact is called a front. When neither air mass pushes into the other, the front between them is called stationary. When the colder air mass retreats from the warmer, its trailing edge is called a warm front. When, however, the colder air mass pushes forward into the warmer, its leading edge is called a cold front. As a cold front advances, its greater density causes it to push in underneath the comparatively moist, warm air in its path and toss it into a sudden, upsweeping motion. As it rushes up into the sky, the moist air reaches its dew point level, then begins to condense. From this point on, it usually starts building up into the violent but beautiful thunderheads called cumulonimbus. The height of a cumulonimbus is closely governed by the altitude of the freezing level within the cloud, which is why it may rise up to as high as 50 to 60,000 feet during hot weather. And the higher it is, the more dangerous. Fortunately for those of us who fly, the outer limits of these atmospheric powerhouses are generally clearly defined. The furious up and down drafts of the cumulonimbus generally lead to short but heavy cloudbursts of large, drenching raindrops directly below its forward portion. Higher up in the cloud around the freezing line, they frequently produce hail, which, if heavy enough, falls to earth. In addition, static created by the turbulence soon builds up powerful positive and negative charges of electricity in segregated parts of the cloud, resulting in the multi-million volt discharges known as lightning. The forward part of a cold front, which usually moves from west to east or northwest to southeast, is like a giant broom sweeping the sky clean and leaving behind it clear, high-pressure atmosphere. Small, localized warm spots in the countryside may, however, create minor updrafts of air, resulting in the puffy white clouds called cumulus. There's a bump in each of these miniature thunderheads, but they are usually easy to avoid. When, however, these cumulus clouds form an unbroken rank, and it is necessary to fly through them, the safest, least turbulent altitude range is between 4,000 and 6,000 feet above the ground. Before we leave the cumulus family, we should mention that the sharply rising air currents and cauliflower clouds associated with cold fronts can also be created by air rising up the windward slopes of steep mountain ranges. When a warm front advances, it leans forward for several hundred miles. The warm air drifts up over the cooler, heavier air at a rather flat angle. Here we will see three high clouds. Cirrus is one of them, often called mare's tails. The cirrocumulus forms as flakes and is called a mackerel sky. Cirrostratus clouds may give the sky just a slight milky appearance. The altostratus is usually a bluish-white cloud letting through a weak, watery sunlight. The altocumulus forms into puffy white rolls. Nimbostratus is a thick gray, shapeless cloud that produces light rain or snow. Stratus is a gray cloud creating low ceilings and poor visibility. Stratocumulus is somewhat like a low altocumulus. Let's review these clouds and altitudes. Cirrus, above 20,000 feet. Cirrocumulus, above 20,000 feet. Cirrostratus, above 20,000 feet. Altostratus, 6,500 to 20,000 feet. Altocumulus, 6,500 to 20,000 feet. Nimbostratus, below 6,500 feet. Stratus, below 6,500 feet. Stratocumulus, below 6,500 feet. As the warm front advances toward the north, light rain or snow begins to fall from the altostratus and nimbostratus. The evaporation of light rain will often cause saturation and condensation that will lower the ceiling. Since the stratiform cloud is composed of small water droplets, rime ice can be a serious hazard. Icing can take place anywhere between 0 degrees centigrade and minus 20 degrees. Icing can also occur, however, in much colder temperatures because water in suspension has the property of supercooling down to as low as minus 40 degrees centigrade and yet retain its liquid globular form until something like the surface of a moving plane comes in contact with it and causes it to solidify. In the thinner, higher type of altostratus clouds, droplets of water can solidify on the leading edges of an aircraft without losing their globular or spherical shape, thus creating rime ice, which is granular in structure and therefore sufficiently brittle to shake off under the stress of flying. A good example of rime ice is the freezing substance which accumulates in the freezing compartment of a refrigerator when it needs defrosting. Calm wind, smooth flying, and continuous precipitation are characteristics of the stratiform clouds in addition to rime ice. Cirriform clouds are composed entirely of ice crystals. Therefore, no ice will form on aircraft while flying through these clouds. The cumulonimbus can be identified by its vertical development. Altocumulus and stratocumulus have a shadow between each row. Cumuliform clouds have turbulence within them. In this cloud, clear ice will be encountered between 0 degrees centigrade and minus 10 degrees centigrade. Rime ice will form at temperatures below minus 10 degrees centigrade. Clear ice can also form if you fly through freezing air and relatively warm rain starts falling from above. A good example of clear ice is an ice cube, which is very cohesive and difficult to break loose. So far in this film, we have related the formation of clouds to frontal conditions. Clouds also develop within air masses. When moist air flows over a warm surface, the bumpy cumuliform clouds tend to develop. On the other hand, moist air flowing over a relatively cold surface tends to create the horizontal stratiform cloud types. In summary, the atmosphere is an outstanding travel route with natural hazards such as severe turbulence, icing, and poor visibility, or just clear skies. Among all the many varieties of clouds, there are 10 basic types which are recognized internationally. If you learn to recognize these 10 cloud types and their symbols, you can avoid or minimize their hidden dangers. Let's review them. The stratocumulus is rippled in appearance. The altocumulus form into puffy white rolls. The altostratus is a bluish-white cloud letting through a weak, watery sunlight. The cumulus is a vertical-type cloud with a flat base. The cirrus form into feathery white clouds, and from the ground they often resemble mares' tails. Stratus is a gray cloud, creating low ceilings and poor visibility. Cumulonimbus, or thunderhead, produces lightning, hail, and rain. The rare cirrocumulus forms in flakes or patches. The nimbostratus is a thick, gray, shapeless cloud that brings light rain or snow. Cirrostratus may give the sky just a slight milky appearance. By studying photographs, you can become familiar with the 10 basic members of the International Cloud family. But the best way to know them is to see them with your own eyes, not only from the ground, but also from the air.